Okay, so today we are going to explain about greedy algorithm method. Greedy algorithm method focus on finding the nearest neighbor and visit all the cities and then return back to the starting point. For this coding, this is the statement that show the matrix for the city A to the city D. We are using the boolean to state that is that the city have already been visited, and then this is part of the coding that show which current city that we are having. For example, we are on the city A. Then this is the program that used to find the nearest city. The calculation where is to count the minimum distance. And then this is the part of the coding where we move to the next city. And then this is the total cost and the path taken for the greedy algorithm. It will return the cost and the path, and then we are going to print it. Okay, that's all from me.
So this is the coding for divide and conquer algorithm. So this is the main function of this coding, which is public static. Recursive function that explore all possible permutation of routers and the best minimum cost. This is for private static. This is the coding for the base case, and this is the coding for computation to find the best way. We must try all visited cities as next step. So this is the output for this algorithm. The output is totally cost 8t, which traveling from path A to B and to D to C and back to the A.
The first function is called dynamic programming TXP. This is the entry point of our DP solution. When this function is called from the main, it set up two important tables. The first one is called memo, which store the minimum cost for each state, so we never calculate the same thing twice. The second is called path, which record the best next city to visit at every step. Once both tables are ready, this function called the helper function to begin solving the problem. The bitmax is number that tell us which city have already been visited. Each bit in the number represent one city. Okay, so this one. If the bit is 1, the city is visited. If it is 0, it has not been visited yet. There are 4 main parts. First, the base case. Second one is called cache. Third, the function loop through every unvisited city. The last one is save the best next city into the path table before returning the minimum cost.
So this method is about backtracking algorithm. So here we use public static method to allow this method be accessed from anywhere in the program. Integer n, since there are 4 rows, is equal to distance, and then minimum cost is equal to integer max value to ensure that the first row will become the current minimum. Here we use private method since it is used internally. If statement here count is equal to n, which is n is 4, meaning that all cities have been visited, it will calculate the total cost by adding the 4 cities with the current cities to A. So here we want to compare if total cost is smaller than minimum cost, the minimum cost will be updated. Also will save the best route after adding to A. And then lastly, the return total cost, meaning that the recursion end and will go back to previous calls. And then next, it will explore next cities here. And then here logical NOT operator will check whether the current cities have been visited or not. If it is not, the algorithm proceed to explore the cities recursively. So for the result here, backtracking minimal distance cost is equal to 80 path A, B, D, C, E.
Based on caution, travelling salesman problem, insertion sort can be used to sort the distance between cities in ascending order. The algorithm compare each distance with the previously sorted distance and insert it into the correct position. This program uses the insertion sort algorithm to sort a number of array in ascending order. It starts from the second element and compare it with the element before it. If the current number is smaller, larger elements are shifted to the right until the correct position is found. The process continues until all elements are sorted. For line 14, start from index 1 because index 0 is already sorted. And then line 20, shift elements that are greater than key to the right. So the algorithm sort the array by inserting each element into its proper position with that already sorted part of the array.
So here we go on for the binary search algorithm. For the first in the binary search, we have a integer sorted array, which is 10, 15, 20, 25, 30, and also 35. We want to find the integer target in this in the array. So the target number is 25. So we starting with the integer left, which is the starting is 0, and the integer right, which is the array length, which is 6. We minus 1, it will be 5. So we go on for the formula, which is if we want to find index mid. So if index mid is smaller than the target, so we must change the integer left. We use formula mid plus 1, and if the mid index is bigger than the target, so we must change the integer right. So how to find the mid? We use formula in the column left plus integer plus left plus right. We divide it by 2, so it will find the index of mid index for the binary search.